Okay, so today we are converting repeating decimals to fractions. In an effort to make today's video shorter, I'm going to just skip ahead to example 2. It says to write each decimal as a fraction in simplest form. And remember, we learned that rational numbers are numbers that can be written as fractions. So we're going to prove that these repeating decimals are rational by writing them as fractions. And remember that a fraction, the definition is that it can be written as a number a over a number b, and a and b are both integers, so no decimals are allowed. Now we're going to look at example 2a. On this number, the repeating bar over there means that that digit repeats on into forever. So we're going to have 6s that just keep going on. And when I think about writing this as a fraction, I can't have any decimals, but I have infinitely many 6s after the decimal. I'd really like to get rid of that repeating part. To start off, I'm going to call this number x. That's going to make it easier to do some math with. And let's see what happens if I just multiply both sides by 10. So on the left side, I would end up with 10x, and it may seem like I'm writing this a little weird. You'll find out why in a minute. And on the other side, well, writing a 0 at the end doesn't quite work when there's no end. So remember that you can multiply by 10 by just moving the decimal one place over to the right. So this other number is going to be 6.666 on forever. Okay, so now that I have that, it seems that multiplying doesn't really do very much. And dividing, I'd still have some numbers after the decimal. So watch this. We're going to subtract, and we're going to subtract the bottom of equation from the top equation, which we've never ever done before. But think about it. When you're solving an equation, you can do the same thing to both sides and have it still be equal. And when I subtract x from the left and 0.66666 from the right, I'm actually subtracting the same number from both sides. So this is legal. We can do this. On the left-hand side, 10x minus 1x equals 9x's. And on the right-hand side, this is the magic part. As I go on forever and ever and ever, I always have 6 lining up over 6, and 6 minus 6 is 0. So this is 0, 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 this is 0. So when I subtract, I'm going to end up getting 6.00000. However, you don't have to write all those zeros. That just equals 6. Yay! That looks so pretty. Now, let's solve for x and see what happens. I'm going to divide by 9 on both sides. And I get x equals. Now, you could enter 6 divided by 9 in your calculator. You might want to try that and see what happens. Fun fact, it's this number. We actually just want to write this number as a fraction, and 6/9 is a fraction, but our instructions said to write it in simplest form. So remember that you divide the top and bottom by the same number. If you can't, then it's already in simplest form. And our x equals 2/3. So 0.6 repeating equals 2/3. Hopefully you already knew that. Now let's go see if we can do this with a weirder number. Okay, I'm gonna first look at what I did. So I multiplied it by a number to get everything to line up. That was this part. Then I subtracted the bigger number and the little number. Then I divided. And then I simplified at the end. That's not so bad. Let's do it on this one. Okay, so I have this number, x equals 0.004, and that whole thing repeats, so it'll go like this. Okay, now to get it so that everything lines up, if I multiply by 10, bad things happen. I'd have like this moved over it'd be 0.04, 004, 004. And if you think that looks wonky, it's because it does. It doesn't work out. So we want to go to the next part where it repeats, like the next little set of 3. So I'm actually going to multiply this so that it moves over 3 digits. And that is the same as multiplying by 1,000. However many digits it moves over is how many zeros there are in the number you multiplied by. So this now will start off with a 4 point, and then I'll have 0, 0, 4. Oh, that looks much better. Okay, our next step after we multiplied was to subtract. Remember that this is a little 1. This will be 999x on the left, and on the right, all those numbers cancel. So I'll have 4. Then I'm going to divide to get x alone. And I get x equals, here's your math magic, 4 over 999. That's the fraction. Now 4 and 999 do not have any common factors, so that is your answer. We could check our answer by actually entering it into a calculator, so I'm going to go ahead and do that over here. I get 4 divided by 999. And hey, look, 0.004, 004. Beautiful. I got the original number. So I would invite you to write your own steps for how to do this, because that's the best way to learn. And let me just, you should try B while we're here, might as well. Pause, try it yourself. Okay, so your answer that you should have gotten for B is 90 90ths, which simplifies to 10 11ths. That's your x. Okay, if you would like to copy down these previously written steps, you can take a screenshot, you can write them down, you could copy them down in your notes. Okay, we're going to go ahead and do this B right here. This one's a little wonky. Our x now equals 0. Well, the 3 is the only thing that repeats, so it looks like this. You can tell what repeats by looking at what digit the bar is over. Now, previously I said however many we get so that we can, however many repeats, that's how many zeros we multiply by. So we actually only have 1 repeating digit. So I'm going to multiply by 10 and just see what happens. Okay, when I move it over 1 to the right, I get 6.33333. Okay, this one still lines up. We're just going to cancel all of these guys when we subtract. And now all I have left is 6.3 minus 0.6. That's actually a number. You can put that in your calculator, but it equals 5.7. Now there is a decimal, but don't panic. It's gonna be okay. 10x minus x equals 9x. And then, like we did before, we're just gonna divide at the end. I have x equals 5.7 over 9, which is lovely. Except we said that a fraction has to have integers in the numerator and the denominator, not decimals. Well, that's a problem. So I'm going to, well, I know I can just make this, we could just multiply that by 10. And what you do on top, you have to do on bottom for this to still be equal. So now it's going to equal 57 90ths. And that's still the same deal. So just multiply to get your decimal out of there. And I'm going to divide by 3 on top and bottom to simplify this guy because I need to. If you don't know how to tell if something's divisible by 3, I recommend just Googling it real quick. It's an easy rule. So then this one, x equals 19 30ths. Now I want to show you a trick that works some of the time. Let's see if there's a pattern here. When I got my non-simplified version of everything, I had 6 over 9 on this guy. Oh, everything is yellow. Hang on. I got 6 over 9 over here. Okay, then on this one, I got 4 over 999. It's kind of weird that it has 9s on both. And we have a 6 in our original number on this one, and then we have a 4 in our original number on this one. So in numbers where the bar is there, you can do this kind of trick. Let's do this over here. We have this one where the bar is over all of the numbers, so it's not going to turn out weird. We can put this, and we'll put the numbers that are there on the top of the fraction. And then however many digits repeat, that's however many 9s go in the bottom. Okay, let's check it. 25 divided by 999. 25 divided by 999. And I get 0.025, 0.025, 025, 025. And that's what my original decimal was. Oh, that is so cool. However, it doesn't work for this kind, where the bar only went over one number instead of both of the ones after the decimal. So on these ones, you have to do the equation. Okay, I have 2 more examples. Try them out, and then I'll reveal their answers. Okay, this first one, our answer was 101 330ths. This one, you could not use that little trick I showed you. And this one, 415 999ths. This one, you can use the trick I just showed you. And you can always check to see if your answer is right by plugging the fraction into your calculator and seeing if it equals the original number.